Thanks a lot to all the members who have been organizing the event. It's been really, really fascinating, and for all the members who are here to attend as well, and of course, the very kind sponsors who have made this all possible. It's really good for me because there are so many members who have talked about some of the building blocks that we will be talking about in this session as well, right? We had members talking about automation, we had members talking about security, just the one before this as well, and then we have also talked about some parts of how some of the solutions can use ML and some of the data governance and principles. How does that all kind of work? We have seen some of that in action. With this particular session, what I'm going to do is I'm going to look at how do you go and really kind of bring this all together? How do you bring a structure to something like this? I'm a data person. I've been doing this for 18 plus years so far, and one of the inherent reasons I do data is because I like things being simple. So let's try to make this simple as well, and let's talk about this. So some introduction has already happened, so I'll probably skip through this. Predominantly on data engineering side, architecture is something that I've done quite a bit as well. I firmly believe in being a builder from the perspectives of teams, product, business values, and obviously storytelling as well. So we said simple. Let's look at very kind of targeted objective that we will have. We will talk about WAF, which is well-architected framework, right? We will also talk about MLOps. The intent is not to kind of really go into the nitty-gritties of that. It's a very brisk conversation on what exactly that is. And then the key crux of the material is actually on the last one, which is WAF plus MLOps. That's where I want to focus on, right? So let's carry on with this. Now, when it comes to well-architected framework, right, you go and look at any solution, something that you have inherited, something that you're creating from scratch, something that you're building with your partners. How do you go and approach architecture? How do you go and make sure that the solution that you're building on has an end-to-end perspective? And the perspectives, they can only be looked upon by having 5 lenses or 5 sides of what exactly are you looking at. Any solution, it has to be secured. You have to look at what cost optimization methodologies or approaches you can use to keep it kind of within the cost. You can also be considering about operational excellence. How are you going to operationalizing it, right? When you have put it in production, one of the things that I generally go and tell my teams and to clients as well, that don't think about what you're doing today, what problem you're solving today. Imagine you have it in production, what you're going to do then. How it's going to look then when it's in production, right? And that's what is the all rigor about operationalizing. And then you have to think about reliability. Now, not everything has to be 24/7 by 365, right? What exactly is it that you're trying to do? How reliable you want the solution to be? And then, of course, around performance efficiency as well. Now, all these different 5 pillars, they have their own specific branches. Let's not be scared. We will elaborate that a bit more once we get onto that, right? But the key aspect is that these are the 5 key pillars. These are the 5 key lenses which can inform you on how your architecture is looking, where you want to be, and where you should be going. And then within that, you have specific elements that you can think about. Now let's jump on to machine learning. Quick show of hands, how many of you associate yourself being a data engineer? Good, okay. Quick show of hands, how many of you associate as absolute machine learning or data science or AI person? Okay, that's good. Quick show of hands for the people who think they're none. Either of these two. Awesome. So let's quickly talk about what machine learning is when it comes to machine learning operations. Again, a very layman lingo. So those who are ML experts, please pardon me, bear with me. Those who are data experts, again, the same thing. Hopefully you will pick up something here. But at the same time, This is more about going towards generalizing the conversation for understanding and building the understanding itself. So when it comes to machine learning, the delivery lifecycle is something that you start with business understanding. What sort of business domain that you're in. Are you retail? Are you anti-money laundering? Are you security? Are you banking? Are you insurance? Whatever that is. And within that as well, what is the aspect of the business that you're trying to target? What is the problem that you think that a traditional application or a software or data warehouse or a data engineering platform, whatever, is not going to solve? And you have to have a machine learning model for that. Once you have that understanding, once you have basically built your understanding of the business, you go towards the data infrastructure, platform building, things like environment setup, things like wrangling of the data, pipelines, and stuff like that. So there is a lot of data engineering work, which is almost like on the borders of data engineering, but with Python and a few other bits and pieces that you probably have seen and heard about. These two components together is what contributes to what we call upon as model development. You have the understanding of the business, you understand the business context, you understand the problem that you're trying to solve, you now understand the data as well, you have a platform for that somehow, right? Presume that's there. That's when you start going towards, okay, let's build some models which solves that, which resolve the problem that you're targeting, basically. And this is where you go, you do the development, you do the training, you basically go and kind of experiment. And once there is a confidence of, yes, this is going well, you basically then go towards deployment or serving that. So you pick one golden version or one golden goose, which is a model which you know is ready, and that is what is going to solve my problem. You basically go and deploy that, and then the new data set comes in, which basically gets exposed to it, and prediction and references or inferences or whatever that happens on top of it. So that's how, kind of very, very loosely speaking, what we see in ML lifecycle. And this is what, once you have exposed this, presumably it's exposed to your end users externally or internally through a web service or through some other mechanisms. Again, very generalized. So what's about this whole MLOps thing in this, right? The ML aspect is definitely around what we have as business, data, all those aspects of what's going on in infrastructure, what models you want to work with. But then development is about training and testing as well. And that's where the CI and CD aspect comes about. We will have a different visual, which will basically elaborate that as well, just to kind of, again, simplify and show visually how I see this happening. So once you have the continuous integration and deployment going on, that's where you go towards the continuous delivery. This is where the ops part comes about, where you want to look at the feedback loop, which is more like you have done something, deployed something as a production service, you get an output, how do you go and feed it back to the main business, so that they can also, continue to consume that. And then, of course, monitoring it. I probably prefer this visual because this kind of, elaborates that a bit more specifically. Now, don't get lost in the whole trail that's there. It has a very specific train, if you think about it. So on the left side, you have the source systems, right? Can be anything. You go and get the ingestion train going from there. So ingestion train is where you go and do certain aspects like cleaning it, validating it, transforming it, labeling it, and a few other bits and pieces. Again, as I said, it's a very generalized version. There are 10 more things that I can add to this. It can be very, very noisy picture. That's not the intent. Once you have that, you basically go and then lead to the next train, which is more around generating the train model, which is where you do some iterative experimentation, training, and tuning of the models. There are multiple ways to do that, right? Not getting into that. But the key aspect is this whole train of getting the data, transforming it, validating it, labeling it, getting it ready for experimentation, then training it and testing it and tuning it and having the model ready. because then you can do the scoring on the model, right? That's the whole process which you can do as a continuous integration. In a continuous integration, otherwise in a software world, what will happen? You will go and have certain binaries or different code objects written by different people, and a service will come, it will build that, and then that build will basically be exposed to certain tests, which hopefully have been coded as well. And if the tests are successful, the system says, yes, this build is successful, and leave it that, and then go to the next rate, right? You can go and say, once a build is successful, you go and deploy to production. And that's what the continuous deployment is all about. The next train which comes after that is the one which is basically continuously taking it to the deployment stage. That continuous deployment stage is also kind of going and putting that model more like a binary object, think of that, putting that binary object in a way and at a place where that can be exposed through a web service, through an API endpoint, or through a Docker image, or through a Kubernetes cluster, whatever, or through Databricks, or whatever that you have going in the business, that can be exposed to the end services and end consumers, basically. Now, this is all kind of there, which is more about not just this, but the key aspect here when you think about this is the elements which are highlighted in yellow, right? These are your milestones. These are your key systems. The process we talked about all of what, right? Since the morning we're talking about that as well. You have systems, source systems. You have compute infrastructure, which is basically for dev and train. Then you have Git repository or code repository. Down below you have your storage services. You have your compute infrastructure, which is used for actual staging or production, right? And then you have a security monitoring services as well. And plus there is a model registry. These are different elements which are key components, tangibles, if I may say, of your solution, of your architecture. And these are the ones that you need to look at from architecture point of view, right? So let's look at what happens. And again, as I said, it's been good that the session on security was right before this. We're going to go and talk about 5 WAF pillars, and we'll start with security. That obviously is one of the biggest in terms of how you go and structure that. So again, the key intent here is to not go and elaborate that to the nth level of detail. This is not it. There are tons of other things that can go beyond this. My intent is to kind of give a flavor of what it entails, basically. So when it comes to security, when I look at any solution from security point of view, I start looking at it from a couple of different areas. How is identity being managed? How is access being managed? Identity and access are 2 different things, by the way, right? Then network or the surface, how are they being managed? How is the protection for data itself is kind of weaved into the solution? How monitoring is weaved specifically for security? So for example, when it comes to identity, do you have a centralized identity access management, or do you have more like a couple of different ways that people can come in and authenticate themselves with? There was a mention of storing your credentials in a secure place. How do you go and manage your keys and credentials centrally, right? How do you go and leverage SSO? So these are the different aspects. Now, when I say all of this, I want to, again, bring some flash of the memory that we just talked about previously. The one visual, which is more like an ellipse on the top, is actually a reminder of what we talked about earlier. We have what we have. We have source systems, we have compute, we have code repository, storage, security monitoring, we have model registry, service endpoint, which is basically exposed to your end consumption tier, and then you have your compute, which is for your serve tier as well, right? Compute tier can be Kubernetes, containers, servers, Databricks, whatever that is. When you look at all these different elements, you can basically pick up just any of these sub-branches on security and put that to all of these different elements that we just talked about. These are the tangibles, as I said, of my architecture. Generally, these will definitely be there, right? Code repository. How do you go and manage your keys? If your ML models are sitting in Git repository, how will you go and access that? Is it central or not? Again, the point that was mentioned, are you storing your credentials in your repository? right? Those kind of things will come about in something that you can work with. Next one is around cost optimization. Again, this can go into so many different ways. We'll probably go on the reverse on this one, because general resourcing is something that we associate ourselves to quite a lot. So resourcing is what, right? When you talk about costing, you can use managed services, you can use experimentation, you can use different other elements of costing. But the key aspect is not just that. It's not just about right sizing. It's also about planning and tracking as well, and reporting on that, right? How are you thinking of your estimates? How are you tracking it? Do you have some mechanism of doing it? And again, think of this from ML models perspective. You have an experiment running on, which can last up to a day or a week. How do you think the cost is going to look like? Is it going to breach the numbers? Is it still intact? If it doesn't breach the numbers, then what do you do, right? Those are the aspects that you need to think about. Moving on to operations excellence, again, automation is something that we have been talking about and hearing about quite a bit. There are certain kind of principles that I generally work with. I've managed productions, I've worked in productions, code everything, but then modularize iteratively as well. Just coding everything doesn't get the job done. You then have to consolidate as well. At some point, you have to think about refactoring. When you modularize it, you can reuse your code. That's the whole intent of doing coding, right? Define your iteration and versioning strategy for data, for model, for environment. All these different elements, they will add to this. And then at the same time, tear down every time. Persistence is luxury when it comes to data. Again, I'm not saying go and drop your databases. What we're doing machine learning operations right now, right? You don't want the whole machine learning extract available all the time. If you're thinking that, then probably you should revisit that. That's not the intent. Okay. And the last one is around reliability, which is more about, if I just jump on quickly, know your numbers. Again, planning is a big aspect in this. What are your SLAs? What are your SLO? What is MTTR, MTDBF? If you don't know these things, think about them. They apply to machine learning as well. You may not be thinking of it from development point of view, but the moment you go and hit production, you need to think about these. If you don't, IT director will ask you to do that. So just be conscious of that. From SRE perspective, think about immutable infrastructure. And obviously, I think that's the one key aspect. Automated everything as much as possible, including testing. And the lastly is around performance efficiency. Again, the same aspect. What are your numbers? What are you targeting for? You want a performance system, but how much performant? Do you want everything come back to you in seconds? If not, then how much? It's hard question business do not know the answers for, unfortunately, and we need to help them on that. And it applies to machine learning as well. And lastly is around monitoring. One bit I'll say on monitoring, not just for performance, but for other aspects of pillars as well. Don't just look at what is my workload, what is my occupancy looking like right now? How much resources I'm consuming? Think of throughput. Think of how much resources you have provided, how much data it has consumed and processed, because that will give you a better indication of what's happening. Because you can get a job done in 10 seconds by using a service which is going to be $10,000 a month, but you can't afford that, right? So think on those lines. Monitoring is not just about monitoring the resources, it actually is about monitoring the throughput, because that's the right value out of this all. Cool. So look, I know I'm a bit short on time. I think I've gone over as well. Apologies for that. Don't be shy. This is the whole thing. If you have any questions, please grab me, and we can definitely talk a bit more on this. Thank you so much.